The next speaker is Mr. Saurabh Mittal from Airtel, where he is Vice President for Standards and Technology, and he is going to talk about 5G deployment in India, the current status.
Okay, so I think the idea basically I have is to give a, brief snapshot in terms of where does India stand, what has been the overall rollout experience so far, what do we see in terms of the smartphone market right now, does it look like, and why it is important. I'll also give a little bit of a glimpse of the what are the policy initiatives from the government side, some key learnings, and then I've also, tried to capture on a few emerging technologies which are important: red cap slicing and millimeter wave. And I hope to keep it interactive. Somehow, at the moment, I'm not able to see the questions or raised hands. So, if someone has a question or raise hand, feel free to interrupt by voice during the presentation. So I'll skip this piece. I'm believing that most of you would have already gone through this piece. Decade of a technology from 1G, 2G, 3G, 4G, and 5G, something which was introduced around 2020s, right? And we are kind of in the early stage of the 5G deployments, if I may say so, and before we evolve to 5G Advanced and 6G later on. I'll later on talk a bit about how the 3GPP release cycle is essentially looking around this. Uh, I think just a recap again, the 5G is, what was the important thing in 5G? 5G essentially created a unified design for all the different kind of spectrum needs and the use case scenarios, which is the enhanced mobile broadband, mission critical services, and massive Internet of Things, right? So I think if you look at these three buckets, and there has been this very popular ITUs triangle diagram when the IMT 2020, which is the ITUs terminology for 5G, was created. You had EMBB, URLCC, and the MMTC. So these three scenarios essentially can be met by a unified design. I think that's something which 5G essentially tried to achieve on this piece, and it covers the spectrum right from sub gigahertz all the way to the millimeter wave, right? And we'll look at how things essentially are at present in different scenarios and what has been deployed, for example, in India, especially with the Indian context as well. Again, I think not sure if this was covered in the previous one, but there is the different spectrum bands which actually have a kind of a balance between coverage, capacity, and latency. So different kind of spectrums essentially lend themselves better to different scenarios, right? So sub gigahertz spectrum, the low bands, they probably are very good for the coverage perspective, right? And you can cover a wide area through the sub gigahertz, right? But from the capacity perspective, that's not probably provides high level of capacity because the amount of spectrum is fairly limited in that spectrum band. And when you go to the other extreme, which is the very high bands, you probably have very high capacity, but the coverage is something which is becoming low or moderate in that regard, right? Similarly, in terms of how the frame structures are done, the latency could be from ultra low to low level related piece. But again, the idea being that there is a common unified design, which essentially is the underpinning technology on the 5G related piece. So you can go from sub gigahertz to the millimeter wave for various kind of requirements, which actually cater to coverage, capacity, or latency, depending upon the use case and scenarios. Uh, just also two other terminologies. I think sometimes we see that they keep coming into the conversation. One is the SA and the NSA related piece. NSA was something which many or most of the operators really started with across the globe, which is essentially using existing 4G network because it was assumed that there is a brownfield deployment, 4G already exists, and hence how can those assets be leveraged to deliver a good experience on the 5G related side as a beginning part. So this is called as the non-standalone network. Here, the 4G core network is essentially used, and the signaling on the radio side for 5G is also done through a 4G anchor layer. We have obviously, if it is non-standalone, then the other side is the standalone, which essentially requires that it can be a completely separate network for 5G with its own core and, of course, the radio resource. So you need a new 5G core, and then there is no dependency on the 4G network related piece. And the data connectivity is with the single 5G radio in this architecture. And why I'm basically giving this particular input is that, if you look at across the globe, what we saw and what we have essentially the reports from the GSA, which is the Global Mobile Infrastructure Suppliers Association. They indicated that uh, about 309 operators. The data could be, I mean, this is little dated data. So a lot of operators have essentially launched with the NSA largely, right? There are only a few handful which essentially did the SA launch. And some of the reasons which are essentially given on the right hand side, right? That the from an adoption perspective and from a device ecosystem perspective, the NSA has been fairly mature related piece. And then you go to the voice part, right? The in most of the networks in 5G, the voice still goes through the 4G network. And in the NSA, because the anchor layer is already on the 4G, there is no impact on the existing voice experience. But in case of SA, what we see is that, most of the networks in the SA, they tend to fall back on 4G for voice, right? And then this creates a higher setup time. There are some operators who are now doing voice over 5G, which is called as voice over NR natively. But there are some challenges which are there, right? I mean, challenges which are written on the bottom of the slide, left hand side, that, in terms of the feature parity, there are some things which are missing still on the 5G standard, and hence it created a kind of a problem in terms of the performance. And in many cases, the handsets were also not really supporting the VNR so far, right? So, for example, the iPhone only recently announced the support of VNR on their handset. Till now, they essentially, and in many iPhone 12, 13, it is still not supported. In terms of the coverage, also we see that if you are using the NSA, especially the Indian bands, in case of India, the 5G is on a 3.5 gigahertz, so the coverage can be a challenge. But NSA, the coverage can be complemented by the 4G layer, so hence it is essentially better. And then the last thing is slicing. I mean, see this later on, right? SA, it is natively supported. In case of NSA, it can still be done in a limited manner, but the challenges that we have seen, that while it is a very good technology from that perspective, but there are not many, I mean, mature use cases around this piece, right? So NSA is something which most people start with, and then they graduate towards the SA as things essentially evolve. Now, how does things look like in India, right? I mean, coming specifically to the India market, India market is the second largest market in the world. Uh, we have about 1,200 million total subscribers, and out of that, 1170, I mean, more than 1,000 million wireless subscribers. So India clearly remains a mobile first country in that sense. The second characteristics of India, I mean, is that, of course, it is the most affordable service globally in terms of the mobile broadband. But the other also important characteristic is that India also has the highest per subscriber consumption. So there is this challenge which comes into picture, that it is most affordable, but then it has also a most usage as well. And this is a challenge for everybody in the ecosystem, especially for the mobile service providers to handle this scenario. And then, of course, the another characteristics which is becoming more and more important is the manufacturing. There is a target of more than 156 billion dollar worth of mobile phone manufacturing by 25-26. So this is also something which is emerging very, very strongly in India. Now, if we, I mean, all the mobile operators in India. I mean, Airtel 5G is launched. Airtel 5G is mainly on NSA, but then SA is something which is work in progress, and it is both being supported, right? So it's not that NSA will move to SA and NSA will discontinue, because many phones support only NSA mode, and hence we are looking to give the choice to the consumer that depending upon their handset, they can essentially select the kind of capability. Jio, of course, has launched 5G, and they have SA completely. Vodafone and BSNL, in our understanding, is still work in progress on that regard. Now, a bit on the spectrum bands. Many of you may be familiar, but I think just to give, recap, the 5G spectrum bands in India, largely, if you look at the top row, 3.5 gigahertz, that's the main spectrum band, because the quantum of spectrum was essentially very large in India. This is 370 megahertz per circle, and Airtel and Jio have about 100 or 130, depending upon the different markets. And VI has about 50 megahertz in 17 circles. Then comes the millimeter wave. Millimeter wave, again, all the three operators have the spectrum in millimeter wave majorly, and the 700 megahertz is a sub gigahertz. Geo has 10 megahertz across all the circles, and BSNL has been also assigned 10 megahertz by the government. Then the 4G bands are essentially mid band and sub gigahertz band, and this is something which is about, which is 21 gigahertz band, 2100 band, 1800, 900, 850, or 2300 in terms of the TDD, right? So these are the different bands, and different operators have 20 to 30 megahertz in these bands, depending upon the different configuration. So the 5G spectrum auction was essentially done in 2022, and government essentially could fetch about 18.9 billion worth of spectrum in this piece. But another important characteristics of spectrum in India is that it is technology neutral. So it's not that the spectrum is assigned as 4G or 5G, right? The operators are free to choose the technology of their choice. And now, for example, if the usage in the 5G increases, then it is possible to reform the spectrum from 4G to 5G if there is enough spectrum available to meet the needs. Now, what has happened since 2022, right? I mentioned that the spectrum auction happened about 2 years ago in August of 2022. So, if you look at how things have essentially evolved in India, the Honorable Prime Minister launched the 5G in October of 2022, which is about 23 months away. That's something which was done in the India Mobile Congress in 2022. And since then, India did one of the fastest 5G rollout across the world, right? So there are now about 450K base stations. So 4.5 lakh base station of 5G essentially have been deployed in a short span of 2 years time frame. And important feature that the 5G is available across all regions in India. So it's not that 5G is deployed only in some cities or in some states or only in urban areas. So if you look at the 5G deployments, it's across all, states, union territories of India. It is across all the districts of India, and there is a very good spread even in the rural areas, which has happened by operators over here. And how it has impacted. If you look at the third party reports, this is not our report, these are the third party reports. On the left hand side, if you look at, this is the UCLA publishes global speed test index, right, where all the different countries are ranked as per the downlink speed. In September 2022, which was just before the, exactly 2 years earlier, this was just before the launch of 5G. India's ranking at that time was 108, global ranking. And now, in June 2024, India's ranking has improved to 12. Now, so this is a very big jump which has happened in the ranking of India, and this is something we believe that that's contributed largely by 5G. So average downlink speed was about 20 Mbps. It has now increased up to 100 Mbps in India. On the right hand side, if you look at, these are the numbers which were published by OpenSignal. This is after the launch of 5G in some parts of India in 2022. So the 5G and 4G comparison is given that 5G was 16.5x faster, and the uh, peak was about 11x faster, so on and so forth. So there is a big improvement which essentially was mentioned in terms of the downlink speed by both Ookla and OpenSignal. Now, also how it has impacted the capacity, right? So uh, India has been, as I mentioned, is very high consuming data consuming market. There is about 20.8 CAGR, I mean, per year growth, which has happened, and India creates now 17.4 exabytes of data per month. These are the reports which essentially published by TRAI and Nokia's Mobile Broadband Index for India. And in 2023, last year, 5G essentially contributed to about 15% of the data consumption. So if you look at, if we plot them together and see them together, the 5G essentially contributed to almost entire or majority part of the capacity growth in India, and it also improved the user experience, right? So generally we see that if the networks were really loaded in India, so 5G really helped to create good capacity in India, and that also resulted into a good user experience. And this is something, I mean, another data point for everyone over here. Sometimes we miss this out. If you look at the availability of 5G, right? Because I said that 5G is available across length and breadth of country. So if you look at many other developed countries, right? Most of the Europe, uh, the Finland has 23% of 5G availability. But in India, and India is leading in Asia, the 5G availability, if you have a 5G phone, the probability that you will be on 5G network is 48.54%. So India ranks very high globally in terms of the 5G availability as well, right? So again, I mean, just to illustrate, right? So there is a tremendous 5G availability. There is capacity growth which was enabled by 5G, and also improved the user experience at the same time, right? So I think from a timing perspective, India has done 5G at a absolutely right amount of time, right time. Also, one last thing in terms of the user experience, right? So, I mean, India ranks very high in terms of the user experience of 5G, both on video and gaming related part, right? So, both operators in India, in that sense, have done tremendous job in rolling out while ensuring there is a very good quality given at the same time. Now, talking a bit about what are the 5G use cases in India market, I mentioned about mobile broadband, B2C. That's obviously the main use case. Then there is FWA, fixed wireless access. I'll give a little bit more details around that part later on. And also then in the B2B related piece. In the morning, Professor Anurag also mentioned about the quality, I mean, the factory automation and what is done in those environments. So whether it is quality inspection, visual inspection, or OT connectivity, right? So there are some experiments which are happening in the private 5G networks as well, or in the B2B segment. Now, shifting gears to smartphone market. This is how the smartphones are essentially looking like. And if you look at, there are the total base of the current base that we have, about 20% handsets are 5G smartphones. But the interesting part is, I mean, again, looking at the right hand side of the slide, let me just, yeah. So on the right hand side, the 5G share of shipment now, about 80% of the new handsets are 5G. But because we had a very large legacy base, and hence of the total base, about 20% is 5G. But the new shipments are starting to shift rapidly towards 5G. So all the handsets that we see in the market, which are more than $200, 100% are 5G capable. The next wave, we believe, will come when the 5G handsets prices drop below $100. That's where the even in the rural segment, the 5G will essentially pick up. And you know, the if we have a good number of 5G handsets, we will be able to do much faster refarming of 4G spectrum to 5G. I think the last thing which I want to highlight is that India is an open device market, which means that the telecom operators in India generally don't sell the handsets as a bundle, which means that as telecom providers, we have to work very closely with the OEMs in terms of what kind of features and capability which need to be brought in, right? But there is no direct control over the same. Now, how also 5G has influenced is and 4G have influenced is to essentially create the digital public infrastructure. And I think most of you know this piece, the jam trinity. So I'll kind of skip this piece. I think mobiles and the mobile networks are essentially one of the important cornerstones of the jam, which is Jandan account, Aadhaar, and mobile related part, right? And it is now enabling about 15 billion transaction per month. A short thing on the FWA related piece. There could be two modes of deployment, indoor and outdoor. I mean, if you look at the operators in India have majorly concentrated on the outdoor solution. The outdoor solution give more consistent experience, and the fixed wireless access is essentially a excellent way of bridging the digital divide, right? Because now you can provide a good high quality broadband service to the areas which were not really connected by the fiber earlier, right? So those deprived areas can be served by the fixed wireless access in a more quicker, faster, and more economical manner. Again, just the glimpse on the private 5G deployments, right? So there are various deployments and experiments which are happening, but of course, real massification is yet to happen. Some quick words on the government policies. Of course, the Indian government had taken large-scale reforms in 2021, which essentially were important for the telecom sector. Then I talked about the spectrum auctions in 2022, which enabled 5G. So not only, I mean, the spectrum was essentially made available where there were a lot of challenges, but then after the completion of the spectrum, it was immediately assigned. This is something because of the enabling policies, and then also to connect this base stations, the government also provided the access to the E-band spectrum for the backhaul related piece, because it's very important that you have enough capacities on while connecting to the base station, right? So that the traffic generated, which could be in GBPS, can be taken back to the data center related location. And then in terms of the ease of doing business by doing digital KYC and the right of way to lay down the fiber, and of course the PLI schemes, which are essentially enabling the mobile manufacturing in India. And then in terms of permitting the innovations, there are schemes which came into the regulatory sandbox, and also the 100 5G use case labs were set up, and ISC Bangalore, one of these labs, is also set up under this scheme. I'll quickly talk about in terms of how things are evolving, and then what is really happening in some of these emerging technologies, and how can they really impact, and what are our key learnings from the deployment so far. First, on the slicing, right? Uh, this triangle we talked about, the enhanced mobile broadband, MMTC, and the URLLC, the ultra reliable low latency communication. Now, I think I would draw your attention to this, table on the right hand side. that the different industry and use cases have different kind of requirements, right? So, for example, energy and utility, the EMBB requirement, because you are sending very small data, this is only telemetry data. The EMBB requirement is essentially low, but the MMTC is essentially high, and the reliability could be, I mean, medium kind of requirement. In case of the above agriculture, the URLC may not be so much important, but of course, the actual scenario depends on the use case. I mean, which can be kind of further broken down into this piece. So when you do a more detailing of these use cases,
DST. DST. Say that again. Yeah. I just want to Rajni from DST, the mail that we got. Rajni?
sorry, is there a question for me? Okay. Okay. Uh, Moving on. So I was saying that depending upon the actual use case, we may be able to put down the requirements of latency, availability, reliability, energy efficiency, and I mean things like these to different metrics. And these metrics, if you try to map on a spider map, right? So it would look something like this. I mean, this has to be done for each and every different kind of a use case. Now, which is around latency, security, efficiency, mobility, I mean, number of connections, reachability, and things like this. Now, what does this mean? Does this mean that for different use case we have to deploy different kind of networks? I think then the answer the industry came out is with regard to the slicing, right? That the 5G network can be uh, sliced in a manner which essentially can be divided into virtual networks, right? Which essentially is defined for a specific business use case, right? So this is how the concept of slicing essentially was created within the industry, within 3GPP, right? That you can have virtual networks on a same physical infrastructure, and then you divide this as per and optimize this as per the real use case of the scenario. Before, just to give some terminology, right? Because I may be using these in the slide, but some of you may not be familiar. When we give the services to consumer, we call this as B2 service, which is like, I mean, general mobile internet, right? Or your mobile calling that you essentially do. Then we have business to business services, which is large enterprises where or the institutes. For example, ISC Bangalore may have taken an internet connection, which is a lease line from Airtel or Jio or any other service provider for that matter. This is generally called as B2B services. We have business to household. This could be again FWA kind of services. I mean, they can categorize into the B2C category only. Then there is a fourth category which is called as B2B2X kind of piece, where the business has essentially taken, but then it might be given to another entity further down the line, right? For example, you can imagine the distributors. For example, let's imagine ITC distributor or ICICI Bank's financial services, right? So in which ICICI is taking services from a service provider, but then it is giving to the end customers or to their own distributors. So this generally can be called as B2B2X kind of service. Now, why I'm saying is that it becomes important in the context of the slicing related piece, right? So the slicing use cases can vary from enterprises to consumers, and then they could be in the category of connectivity, adjacency, and the innovation related piece, right? So which means that there could be just EMBB or FWA use cases, or there could be scenarios like gaming, which is to the consumer, or the private networks, which is from an industrial use case perspective. Now, what essentially has happened across the globe in terms of different use cases, right? So, as I said, that it could be the extreme scenario is that there is a network-wide virtualized enterprise network, right? So, uh, for example, a logistic company needs a countrywide network, right? Then instead of deploying dedicated infrastructure, there could be a slice which can be created, and this can be given. Then there is vertical slices, the fixed wireless access slice, slicing for applications, which is essentially saying that, for example, we are doing this conference call and you are attending this on mobile. Now, these kind of calls are susceptible to packet loss and things like this. So, can there be application-oriented slicing which can be done? And last but not the least is, of course, on-demand slicing that the consumer really wants it. Now, on the slide, what you see are some of the use cases which essentially have been done. I'll just pick up two scenarios which are essentially deployed, which are important. First is the Singtel's scenario. Singtel is, as part of Airtel, this is kind of a sister association, and they are the largest operator in Singapore. They started with NSA launch in 2022 and then went on to launch SA. Now they have deployed baseline slicing in last year. Now the use case is essentially from their F1 race, right? So the Formula One race in Singapore is extremely popular. It's well attended event, and Singtel essentially deployed the slicing to prioritize certain users who wanted to actually click photographs in the event, send to their friends, family from the event, right? So because the uplink can get really choked at that point of time, and hence that slicing was essentially created. So last year, in addition to that particular scenario, there are also many law enforcement agencies, police, and many other personnel who also need a guaranteed service at that point of time. So the Singtel in 2023 created another slice, which was essentially given to the public safety agencies for their important work that they do. And this was prioritized even on top of the platinum users, which were there from the event, who were essentially still doing the upload and those kind of services, right? So there were priority based admission controls done for the slicing related use case. But I mean, is this something which can be really massified? Uh, the industry is still working on that part. So this is another case study which is from the Telenor Norway and Vini. Vini is very interesting consortium. This is the 5G verticals innovation infrastructure. This consortium was created in Europe by 23 partners. So this includes like CSPs, network vendors, researcher, academics, to look at multi-vendor, multinational 5G environment. So Telenor in this particular case study, along with 5G Vini and Nokia, they implemented network slices. One was essentially for the Norwegian armed force, right? So they can essentially use the same infrastructure and ensure high reliability and high security across different sites. People who are interested, I have given the link below. I will encourage them to look into more details. This is widely publicized by Vinny as to what they were able to do and how they are able to ensure the needs of a different industry for critical KPIs as per their industry. Uh, Cloud gaming is also another important use case which generally is talked about, wherein it is believed that this is a popular scenario of the consumer use case. And Vodafone Ericsson, they tried out the 5G standalone network slice for cloud gaming, right? Over here. But what are the challenges, right? I mean, practically speaking, we know that slicing looks very good, but why is not so much implemented? There is obviously a complexity in terms of implementation. There are many moving parts of the solution, and then the major part is the lack of common interfaces on the business side, that which users, while the 3GPP has defined the slicing standard, right, but then how the consumers are going to use it, I think that remains very different implementation by different people, and it becomes very complex to actually look at. The other thing is that no compelling use case. Whether Because I said that 5G, there is huge capacity which is created, so the capacity is not a constraint, and hence people are probably not willing to pay a premium for these kind of services. I think that's a challenge, and in some markets, there is also a debate going on whether it fringes on the net neutrality or not. I think that's another piece which is there. And for some people, the alternate is to actually look at the private 5G itself, right? So you really don't need a slice in that sense. So there are several factors which essentially our industry is working on to make the slicing more consistent, the user experience more consistent, to have better onboarding, and also actually to look at how can these use cases be more compelling to the end customers, right? And we see that people can deploy the slicing for internal use case and then discuss more with the enterprise customers to look at how can there be a more mature market for this. I think the other topic that I really wanted to talk about is the red cap devices. Now, red cap is a very interesting device. It's a big switchover from slicing to the red cap. Uh, you know, red cap is nothing but reduced capability. If you look at this diagram, the EMBB, URLCC, and the MMTC was essentially created. The EMBB and URLCC are premium 5G, right? So you need high-end capability in the devices to provide high capacity or high reliable services. But then if you had the MMTC, most of this gravitated towards the LTE related part or the NB-IoT related piece. So somewhere in between, there was a need which was felt that we need to create another set of devices, which is called as a reduced capability of 5G, right? And okay, maybe this is a good example to essentially illustrate that part. The EMMB URLCC needed very high performance, and hence, sorry, first to explain the this chart, right? So this has the on the y-axis the complexity of the device, on the x-axis the performance of the device. Now, for the 5G mainstream, you need to be high on the performance, and the device also becomes a complex. On the low end, it essentially falls down to NB-IoT as such, and NB-IoT is a 5G family of technologies. Now, somewhere in between, there was a need felt to have complexity, low power kind of requirement, and that's how the genesis of RedCap came into picture. RedCap is nothing but reduced capability. So you are reducing the capability from the device in that sense, and I mean, this is something which is reduced from a complexity. This is being reduced in terms of performance. And what's the use case? The use case is the consumer IoT. For example, wearable watches which are there, right? So it is expected that they will become the red cap devices, and the industrial IoTs like video cameras, car devices, machine automation related piece, right? They don't have high broadband needs. They do not have the high URLC needs in general, right? So as a result, the capabilities could be reduced. This will make the device cheaper and more affordable. What changes? This table essentially gives a good understanding of how the devices look like in the FR1, the mainstream release 15, and a red cap device. So for example, the minimum requirement was 100 megahertz. This is relaxed to 20 megahertz. Then the receive was 2 or 4 depending upon the frequency. This is further relaxed to 1 transmit, 1 receive, which is possible. And the MIMO related requirements, they have been relaxed. The modulation has been relaxed. What essentially all this means is that the device could be less complex, and as a result of that, it essentially will be cheaper to essentially create a red cap device. Similarly, there are some changes which are done in the FR2 also. While we'll park the FR2 for the time being in this piece. So the result has been that the red cap is going to expand the device ecosystem in general. The third is important aspect, which is millimeter wave. Millimeter wave, also called as FR2. This is something. This is a global snapshot, right? In North America, the operators have launched the millimeter wave. Verizon, AT&T. In Northeast Asia or East Asia, This has been launched by Japan in Japan. In Korea, I, I mean the operators actually gave back the spectrum of millimeter wave. In China, we understand that the trials are going on, but the actual allocation has still not taken place. Right. In case of Europe, there is very limited. There are trials which are going on, but very limited deployment which has happened. And similarly, in Asia also, sorry, in India, Airtel and Jio both have the license, but there is no commercial, large scale commercial done in the millimeter wave. What are the use cases? Use cases, of course, is the fixed wireless access. There could be hot zones, stadiums, and there could be industrial deployment. But if you look at India market, right, let me begin by hotspot and the stadium requirement. The handsets do not support millimeter wave in India. So none of the handsets sold in India support millimeter wave. Even the iPhones, the ones in the US support millimeter wave, but the ones in India they do not support millimeter wave. So the use cases and applications then are either around the fixed wireless or in terms of the industrial related piece. But what we see is that the millimeter wave deployment is going through a rethink globally, right? I mean, people are really thinking what kind of use cases, scenarios, millimeter wave will be really, really useful. Now, coming to the challenges and learning from 5G, what we have seen so far. I'll kind of skip this piece, but just to say that there are issues that we see in terms of devices, in terms of as I mentioned, the all the handset, even though they may be supporting 5G, but their software may not be really enabled properly, and there is a lot of work which needs to be done in terms of the access network. How do you do the transport? How do you ensure the bandwidth? How do you actually do an anchoring or the handovers? I think that's something which is critical. Core node needs to be, fully dimensioned for the signaling related part, because it is high in both SA and NSA scenario. In case of SA, if you are doing the fallback from 5G to 4G for voice call, there is additional signaling which gets added. And if you are doing NSA, then the 4G network elements, there is significant signaling which also is getting added. You need to look at how do you do the automation, and also nuts and bolts of the technology and the towers itself, right? Because these are like massive MIMO radios, and how do you handle the entire infrastructure on this piece? So I think important message is that there has to be a cross-functional effort to handle the 5G readiness, right? So one part is technology, but to deploy, you need to make readiness devices in terms of the transport network, core network, also the infrastructure, and how do you do the overall site design and planning part. The other challenge and our learning, right, that in terms of the use cases, uh, there are potential, but then there is no real monetization as of now, right? And then there is a issue in terms of the cost and the power consumption. As I mentioned, that there are like no 5G IoT devices. This will start to come out this year. In terms of the red cap devices, and the millimeter wave ecosystem is very poor. So what do we need to do to handle this is that, of course, we are looking at FWA, which essentially can handle, and then the how do we actually look at the improving the energy efficiency within the telecom networks and build the millimeter wave ecosystem. In terms of the B2B and the enterprise market, we need more maturity in use cases, better industry partnership, right? We've been working with ISC Bangalore as to what can be done to essentially for various 5G use cases, right? So similarly, more partnerships between industry, academia, and the enterprises needed to drive these use cases. And of course, we need to work on improving the Internet of Things and the edge cloud as well, to give a really good performance and solid use cases to the enterprises. I think how things are looking in terms of the 3GPP release cycle. So release 15, 16, 17 is of course the platform baseline 5G. Most of the networks around the world are released 15 and 16. I think this is the same case in India. that networks in India are largely between release 15 and 16. They will essentially get upgraded to release 17 in time to come, which is when the red cap and associated things will get introduced. And then this paves the way to the 5G advance, which is release 18 and 19. Release 18 is just kind of, closed, and release 19, the work is going on. And the early work on the release 20 is something which is going to get started next year. So this is together, these three releases will create 5G advance, right? And then release 21 is what essentially will be 6G. The actual standardization is expected to close around 2030, 2029 timeframe. A lot of study item is essentially going to get started in release 20 itself, right? Which is will be actually for creating a foundation for the time to come in that part. So, what are our key learnings from the 5G overall, right? As I said, that we need more user use cases, capacity, efficiency, openness, and trust. So we need more, but less carbon footprint, less energy consumption, less complexity, and less device cost. And of course, there has to be more intelligence, which essentially comes into picture, right? So we need to improve and work and the ways of improving the productivity and efficiency for us. So how things look like for India? If you look at, this is the Ericsson's mobility report. There's the forecast for India in terms of the subscription. 5G will, we believe, it would overtake 4G around 2029, 2030 timeframe. This is like similar situation across the world as well, and there will be 5G in all the different types of band, low band, mid band, and the high band most likely. And of course, the standalone will be the most large scale deployment that essentially will be there. And last but not the least, right? Of course, there is going to be growth of, both 3GPP and non 3GPP based technology like Wi-Fi 7 and 8 probably would also be available. And of course, there is going to be large 5G and LT based IoT devices which will be available onto this piece. So this is extract from the Bharat 6G Alliance input to 3GPP workshop, which happened earlier this year. And some of the learnings, I think I would quickly start with the fact that in terms of 5G, there was a big gap in the vision and the first release of 5G, right? So we always talk about these different use cases, but at the end of day, the mobile broadband has been the biggest use case so far in these initial releases of 5G, right? And then we need to look at how the vertical industries they mature in 5G overall related piece. And as I said, that the FR2 or the millimeter wave, how do we commercialize the mobile broadband? That remains a challenge. So this gives an opportunity to say that can the FR2 or millimeter wave be more suitably tuned to fixed wireless access kind of technologies, right? I think the other key thing is that sustainability and the energy efficiency, which was kind of afterthought. This really needs to be handled much better when we look at the 60 related piece. And also, maybe we need to have more simplification in the migration steps related part. So I think the other important piece is maybe the other last piece on this piece is that 3GPP, within 3GPP and all the other ecosystem partners, we are looking to have more open interfaces and have no vendor lock-in while we talk about the 60 related track. Again, these are some of the extracts from the Bharat 6G Alliance, and people who are interested, I'll request them, right? They can look at the 3GPP SA workshop. Many of the inputs from Bharat 6G Alliance and as well as the other regional alliances are essentially available there. With that, I come to the end of my talk and happy to take any questions